This is the second part of the feedback journey lecture. We have completed the first part by having a Spring Boot form through which users can submit feedback and a method in the controller to handle the form submission. Currently, this method prints the form content to the console. To complete the send feedback journey, we need to introduce Spring configuration for development and production. Why is this important? If we want our application to be scalable and ready for the cloud, as well as being automatically deployable to a number of different environments, we need to keep the code separated from its configuration. This means that, in order for the application to run correctly in different environments, we should change configuration at runtime, not the code. Imagine that you are a developer, and when running locally, you want to use an in-memory database and you don't want to send emails for real. However, when the application is running in a production environment, you want it to connect to a real database, perhaps MySQL or a NoSQL database, and you want it to send real emails. The code base for both scenarios shouldn't change. What should change instead is the configuration. Basically, we need a mechanism to tell Spring, if you are running in a development environment, do this. If you are running in a production environment, do that. With Spring 4, this is possible thanks to external properties and profiles. With external properties, we externalize the application configuration in external property files. We will have a property file for production and one for development. We might also have a common property file for both scenarios. Then, we will have two different Spring profiles, one for development and one for production. We will also have two different Java configuration classes, one that will be used when running with the development profile and one for the production profile. Let's see how we can do this. First, we will create a development and a production property file. If you remember from the lecture on Stripe, we have created a .devops body folder under your home folder, where we have placed the stripe.properties file. Let's open a command prompt and point to the same location. Then, we can create an empty properties file for development with the command touch application-dev.properties. And we can create an application-prod.properties file to which we will add a few properties. Please pause the video and take time to copy exactly what you see on the screen. I'm using a Gmail setup to send emails. If you don't have a Gmail account, you can always create one for free for the purpose of this course, or you might want to change the details to those of your email provider. I'm obviously obfuscating sensitive details, as I don't want the entire world to see them. You will need to replace the credentials with your own. Once done, save the file and exit the editor. You will also want to change the security of your files by executing the command changemod 600 star.properties. This will allow only you to read and write these files, but will deny access to anyone else. Now, we will create a couple of Spring Java configuration classes, one for dev and one for prod. Right-click on the config package and select New Class and name it Development Config. As seen in previous lectures, to tell Spring that this is a configuration class, we need to annotate it with the @configuration annotation. We will also need to add the @profile annotation and specify dev as value, so that Spring will load it only when the active profile is dev. Finally, we will add an annotation that we have never encountered so far, called property source, to which we will assign the value file : $, curly brace, user.home, curly brace, /.devopsbuddy, /application-dev.properties. The Java property @user_home will resolve to your home folder. You should make sure that the .devopsbuddy folder has been created under your home folder and that you specify the protocol file : // or Spring won't find the property file. Now we will repeat the same process by creating a production config class, which we will name production configuration. Again, we will annotate it with the @configuration annotation, but this time we will specify the value prod for the @profile annotation. Finally, we will point the property source annotation to the application-prod.properties file. By now, you will probably be wondering, How do we tell Spring which profile to run with? There are several ways to achieve this. When we will be deploying to Amazon Web Services, we will use a system property via the command line. For now, since we are developing, we will simply be adding a property to the application.properties file under the source main resources folder. If for some reason you don't have this file, just create an empty one and follow what I'm doing next. We will define the property spring.profiles.active and assign it the value dev. Now, let's put it all together. When we start the application, Spring will look at the application.properties file under the source main resources folder by default. It will recognize the spring.profiles.active property and get the list of all active profiles. That's right, we can use more than one active profile. For argument's sake, let's say that we want to run with the dev profile. Spring will load all the configuration classes which either have a @profile annotation with the value dev or which don't have any @profile annotation. In our case, since we have annotated the development config class with the @profile annotation and has specified the value dev, Spring will load the development config class as part of the configuration bootstrap. This class will load all properties contained in the application-dev.properties file and make them available to every Spring bean. Once the properties are loaded in the Spring context, we can access them with the @value annotation, of which we will see an example soon. Great! Now that we have our development and production configuration set up, it's time to create the email service. We will want to have a mock email service which will simply log the email message to the console when running with the dev profile, and one SMTP email service which will send real emails when running with the prod profile. Before we can start coding our service, we need to add the Spring Boot email dependency to the POM file. This is as easy as adding the Spring Boot starter mail dependency. We can add it to the Spring Boot session in the pom.xml file. This dependency will add all dependencies required to send emails to the class path, including JavaX mail and JavaX activation. How are we going to code two different email services? The answer is polymorphism. Every time you have two or more different implementations of a given functionality, you want to create an interface to define the contract, and then different classes implementing that interface, although providing different behavior. This is an implementation of the GOOF strategy pattern. GOOF is a nice name for GOF, which stands for Gang of Four. In 1994, Eric Gamma, Richard Helm, Ralph Johnson, and John Blisides wrote a book on design patterns, which rapidly became a must-know for all IT professionals wishing to write architecturally correct systems. To find out more, just Google Gang of Four design patterns and you will find thousands of links. We will instruct Spring to initialize either the mock mail service or the SMTP one based on the active profile. We can do this by injecting the email service as an interface. Spring will take care of everything else. First, let's create an email service interface under the backend service package. We will call it email service. We will add two methods to this interface. The first will be named sendFeedbackEmail and will accept the feedback POJO as argument. Since this is an interface method, we will also add some JavaDoc documentation. The second will be named sendGenericEmailMessage and will accept the SimpleMailMessage argument. Again, we will add some JavaDoc documentation to help users of this API understand what this method does. We will also create an abstract email service class, which implements the interface and provides some common functionality, such as creating a simple email message object from a feedback POJO. This is one of the implementations of the GOOF adapter pattern. In the abstract class, we will create a protected method named prepareSimpleMailMessage from feedback POJO, which will accept a feedback POJO as argument and return a simple mail message ready to be sent via email. We will add a default toAddress property to the application.properties file. As value, I'll enter my email address, but you should enter your own. Then, we will inject into the abstract email service class a string named default toAddress, and we'll use the @value annotation with the value $default toAddress between curly braces. At runtime, Spring will initialize this variable with the property value which we have defined in the application.properties file. I'm now going to paste some code I've prepared for this lecture, and then I will talk you through it. Feel free to pause the video and follow exactly what you see on the screen. From the code, you can see that first, we create a simple mail message object. Then, we set the to, from, subject and text properties. The to property comes from the property we have just defined in the application.properties file. This is the address to which the email will be sent to. All other values come from the feedback POJO object. The from attribute defines who the email comes from. The subject is the email subject and the text is the email body content. In the abstract email service, we will also implement the send feedback email method, as both email service implementations will use it. Basically, this method gets a simple mail message object from the method we have just defined, and delegates to the send generic message method the job of sending the email. The send generic message implementation is really the only difference between the two services. The mock service will simply log the message to the console, while the SMTP email service will actually use a Spring Mail sender to send a real email. You will notice that the send feedback email method in the abstract class invokes the send generic email message method, although this has not been defined in the class. This is the implementation of the goof template method pattern, and it's possible because we are in an abstract class, therefore the method definition is taken from the interface. Depending on the runtime email service that we will use, either the mock email service or the SMTP email service will be used as implementation. Now we can create a mock email service class which extends abstract email service and which implements the send generic message method. We will declare an SLF4J logger, as the only activity this class will perform is to log the message content to the console. Then, in the send feedback email method, we add a few log messages just to make sure things are working properly. We want to create a mock mail service bin in the development configuration class. To do this, we will create a public method named email service, which returns an email service type, and annotate it with the @bin annotation. This method creates and returns a new instance of mock email service. Now, we can inject the email service into the contact controller, and to do this, we will declare an email service property, making sure that we use the interface as type, not the implementation class. We will also need to make sure that we will annotate this property with the auto-wired annotation. Then, in the contact post method, before returning the view name, we will invoke the send feedback email method on the email service interface, passing the feedback POJO as parameter. If we restart the application and go through the Contact Us journey, when submitting the form, we should see the log messages in the console. We can now create the SMTP email service. Like we did for the mock email service, we needed to extend the abstract email service class. We will first declare a logger, as we want to keep track of what our application is doing. In this class, we will use the mail sender bin that Spring Boot automatically initializes for us when we have declared the Spring Boot mail dependency. We will therefore declare a variable of type mail sender and inject it with the auto-wire annotation. Then we will write a few log messages and invoke the mail sender.send method to send the actual email. Please note that because we have defined the spring.mail properties in the application prod properties file, Spring automatically configured the mail sender with all the right values. All we had to do was to invoke the send method. This is just one of the examples which demonstrates the power of Spring Boot auto-configuration compared with the traditional approach. Now we need to declare the SMTP mail service bin in the production configuration class. We will declare a public method that returns an email service type and annotate it with the @bin annotation. Inside this method, we will create and return a new instance of SMTP email service. To test this out, we need to change the active profile in application.properties to prod. If we restart the application now and go through the Contact Us journey, we should receive an email in our inbox. Please note that we haven't changed a line of code in the controller. This is what we should strive to achieve, and this is the power of keeping the configuration and the application code separate, as well as using polymorphism. We have observed two completely different behaviors by simply changing the active profile from dev to prod. The last thing we need to do is to close the git flow workflow. As usual, first we will push the current code to the remote repository with the git commands git add star, git commit -m added the feedback journey code, and git push. Then we will merge the feature branch feedback to develop with the commands git checkout develop, git merge feedback, and finally git push. Phew! We made it to the end. We have gone through a lot in this lecture. Well done! First, we have seen how to create a Bootstrap form, how to handle it from a controller, and how Spring does a lot of the boilerplate work for us by automatically filling a Podio with form data. Then, we have seen how keeping the configuration separate from the code helps with developing truly scalable and runtime ubiquitous application. We have seen the power of external configuration combined with Spring profiles to modify the application runtime behavior by creating a development and a production configuration class. We have learned few important goof patterns, namely the adapter pattern through an abstract class, the strategy pattern by having different implementations of the same interface, and the template method pattern, which is the ability for an abstract class to delegate to a method implemented by its children the runtime behavior. Finally, we have learned how to use a Spring Boot email to send real emails. In this lecture, we haven't covered form validation. Later in the course, there will be a lecture dedicated to this topic, when we will be discussing the form validation JavaScript library. In the next session, we will start protecting our website content with Spring Security, starting with an in-memory configuration and then moving to a database configuration with Spring Boot Data JPA. Thank you for your time, and I see you in the next lecture.